Okay, so here we can see the tools of the trade. These are a few different styles of drill bits that you can use to drill fastener heads. To the left, the first set, these are high-speed steel bits. On the left is 16th inch, and on the right is 3/32. I typically recommend using a 3/32 bit whenever possible. You get down into the 16th inch range, and you'll have problems with tool breakage. High-speed steel, really not suitable for drilling almost any material of fastener. Fasteners use hardened metals, very strong, very hard on bits. You really won't get very good tool life out of high-speed steel. The next set, I have a bunch of these. These are the bits I use the most, and they are solid cobalt, 3/32 stub length. You can see they're shorter than some of the other designs. They're shorter than the jobber length high-speed steel that we talked about. The shorter length makes the bit stiffer, so you'll have less problems with walking. You'll have less problems drilling straight holes. I prefer to use stub length drills whenever possible. To their right is the same style bit, solid cobalt, except this is just jobber length. I use these whenever I need to drill a hole that's deeper than you can drill with a stub length. Doesn't come up very often. I don't use them very often. In the center is a solid carbide bit drill, and solid carbide is a lot harder than cobalt. You can get through harder materials with the carbide. However, it's very brittle, so you need to use a lot of care to make sure that when you chuck all of your parts, everything is stiff, your machine is stiff, otherwise you'll have problems chipping or breaking. The good news with the carbide is if it does break, it's very easy to get out of the fastener. The whatever remains inside the hole can be knocked out, broken apart with an awl or a punch or whatever you have on hand. Now these guys are straight flute, stub length, solid carbide bits. The straight flute ones are really nice. They've got a lot more meat to them than the helical flute ones. They are stronger, they're less likely to break, and they also do not walk on the material. However, due to the straight flutes, they don't remove material very well from the hole, so they don't remove chips very well from the hole, so you need to back them out and clean them out frequently. Also, as you can see, the cutting surface is quite short, so you cannot drill very deep. The next one is a center drill. It's hard to see in the video, but it has a very, very small tip. I use these on fasteners where I think I'm going to have a problem with the bit walking, so I'll use these to create a point on the head where the next bit can start easily. And then to the right we have three different kinds of countersinks. This guy and this guy are zero flute countersinks. I use these primarily. This one is high-speed steel. This one is solid cobalt. And they're really nice because they don't chatter, especially with some of these little holes. If your machinery is not very, very stiff, you can have chatter problems with more traditional designs. And the one on the right here is a solid carbide countersink, 4 flute, much more traditional design. They're nice because they come to a point, so you can do very, very small holes. However, I find that, again, unless you have a very, very stiff tooling, you have chatter problems and your countersink finish won't be very good. So why bother countersinking at all? Well, if you drill a good hole, you have a pretty smooth finish, but you still have a bit of a sharp edge at the entrance and exit point. And remember, your lock wire is going to be right on that edge. It's going to be bent around that edge. So I like to knock that edge down with the countersink. So here's my basic drill press setup. It's something very commonly available, Craftsman 2/3 horsepower benchtop setup. Adjustable speed. I typically like to run about 1,000 RPM when I'm drilling fastener heads. As you can see, this is Really nothing fancy. Pretty basic, you know, $150. And then looking at my clamping setup, again, pretty basic. This is about a $100 clamp. It's made by Palmgren. As you can see in the top here, it's got a little slot in the jaws that I find fits fasteners very well. It holds the circular fasteners quite well, considering, they're a circular shape, but it doesn't do any damage to the threads. I really like this design. It works well with the benchtop drill press. And like any good shop, everyone's got their favorite kind of lube. Right now I'm using Anchor Lube. I like it. I don't use a lot of it, but it works well. And here you can see the fastener and the drill that we'll be using. Alright, let's get this thing chucked up and get started. One thing I forgot to mention, always use eye protection. Everyone's got their own style with this. I prefer the aviators myself, the aviator safety glasses. If you're going to be doing this and you're going to be wearing glasses, you might as well look stylish. Okay, so first thing we're going to do before we start drilling is chuck the drill, of course. Helps to go the right direction. And we'll install the fastener in the clamp. Now there's a lot of trial and error in figuring out what works best for you. I've done a lot of these. I know what works for me. Everyone's got their own style. Now before I get started, make sure everything's tight. I'll put just a little dab of lube on the fastener. If I can get any out here. Okay, let's get started. Safety glasses on. Now I'm putting just very light pressure. Again, this is very hard material. You don't want to go too fast. You can see there's a good chip buildup here. We're getting nice long chips, which means we're hitting a pretty good speed and a pretty good feed. Now I'll bring it out briefly to check on everything. And we'll keep going. The machine's running nice and quiet. That's a good sign. And I'll just make one small adjustment to the machine here because I see it walking a very little bit. Or I saw that it did walk a very little bit. And we'll keep going. And I'll stop briefly to clean off the shavings and put a little more lube on. Doing these fasteners is a pretty slow process. Not many people do this. If you're interested in doing it, you can't find the fasteners you want pre-drilled. Unfortunately, it takes a little bit of time, but at least by following these instructions, hopefully you'll go through less broken equipment than I did when I was figuring this out. Again, very light pressure on the handle of the drill press. Let the drill do the work. Keep an eye on the shavings coming out. They should be, medium sized. If you ever feel the drill isn't working anymore, go ahead and stop and change drills. Once you get one of these drills stuck in the head, it's basically a throwaway bolt. Now you'll want to pay attention once you think you're getting close to the bottom of the fastener. Is one of the hardest things for the drill to do is to break through the back end of the fastener. You want to make sure, and you'll get a feel for this, is when you're getting close to the end, you'll feel the, you can actually feel the bit working as it's trying to break through the end. Ease up on your pressure a little bit, and that will prevent broken drills. Now I'm getting fairly close here, I think. And I can feel it pressure lightening up. I know we're coming through the backside, and you can see it all the way through there. Once you feel that pressure lightening up, just make sure you reduce your feed on the handles in order to make sure you don't break that drill. Okay, I'd just like to clean my tools here a little bit. Let's take this out and see how this looks. Let's see if we can get it to focus here. You can see a nicely drilled hole. A little hard to see on camera, but we have a very nice smooth hole. That we were looking at the entrance there. Let's take a look at the exit. Very nice and clean. Now you'll typically have a routine. You know, if I'm drilling 8 of these, I'll drill all 8 before I change tools. But for the sake of showing you guys the process, I'm going to take the drill out of the chuck, and I'm going to chuck up my Cobalt Zero Flute countersink, and we're going to countersink both sides of this fastener. Whoops, got it chucked a little off here. There we are. Take a look that everything's still lined up. And tighten everything down. Alright, here we go. I typically don't use lube for this operation. You're not really removing a lot of material, you're not creating that much heat, and I like to see what's going on. Okay, turn the machine off. That was quick. All it takes is, you know, a quick quarter, half second. Let's take a look at that, see if we can get this on camera here. Kind of hard to see probably, but you can, if you can tell, we have a beautiful countersink here. Alright, let's do the other side. Again, we'll check alignment, make sure everything looks good, and let's do it. See, I didn't have the clamp quite tight enough there, but everything turned out pretty well. Okay, there it is. So now all we have to do is do a handful more.